For the following exercises, evaluate the expressions, writing the result as a simplified complex number. You got it. Okay, so we've done tons of problems with complex numbers. They're all on our complex number playlist, which the link is in the description if you guys aren't on the playlist. It's just easier to, look back at different problems that you guys want to look at. So this one will be kind of like a quick inversion because we've already talked about the rules in the previous lessons, but we're still going to go through it, right? So let's go. Okay, so we need to simplify this blob into a simplified complex number, right? It's 1 plus 3i times 2 minus 4i over 1 plus 2i. Okay, so we're dealing with i's, and remember, I is just an imaginary number. It doesn't really exist. It's not real. It's non-real. By definition, it's the square root of a -1. If you try to plug in a square root of any negative number in your calculator, do it now. Do like the square root of -4. The calculator is going to say, sorry, I can't compute that. It's going to say error because you can't have a negative in a square root. So the calculator doesn't understand. These are imaginary numbers. So we just denote them as I. There are a couple of rules, right? We know that I, the imaginary part, cannot be in the denominator. So we have to somehow get it out of the denominator. But I'm not going to worry about that just yet because I see that I can simplify these things on the top. So what I'm going to do is I'm just going to work over here, right? I'm going to say 1 plus 3i all multiplied by 2 minus 4i. I'm going to simplify. This is the play it fair method. I have a first term, 1, and I'm multiplying it by the second term, and I need to be fair. I need to multiply the 1 by the 2, but I also need to multiply the 1 by the -4i. But then I got to be even more fair, because if I'm multiplying the 1, I need to multiply the 3i, and I got to be fair. This needs to be multiplied by 2, and then the 3i also needs to be multiplied by -4i. So whenever you see this like double bubble, they call it, or double parentheses, you're always doing 4 multiplication steps. 1, 2, 3, 4. 4 multiplication. Okay, let's simplify. So 1 times 2 is just 2. 1 times a -4i is a -4i. 3i times 2, we're working with the second one here. 3i times 2 is a positive 6i. 3i times a -4i is a -12i squared. Now we just have to simplify this. Well, I see that I have 2 like terms in the middle. I have 2 I values, so I can simplify that, right? -4i plus 6i, -4 plus 6 is a 2. So this would turn into just a 2i. And then I just strap in all the other ones. This is a positive 2, so that's why it's now plus 2. So it would be 2, I'm just bringing the 2 down below, plus 2i minus 12i squared. Okay, simplified complex notation, however, says, we're only allowed to have one I in our answer. I can't have I squared or I to cubed or I to the 4th. So this is a problem now. There's just so many problems, but we can conquer them all. So I have an I squared here. So if I go back to my notation of what I really is, if I am saying I have 2 i's now, or I squared, I'm just plugging in the I value squared, right? And if I go so far as saying, if I just drag this a little bit out, and I say, well, what is I? I was this. So if I just erase my I, and I just write down the square root of -1, I'm doing that squared. And what is a square root and then being squared by each other? They're opposites, right? So they cancel each other out. And I'm left with just the number -1. And that's why I squared just equals a -1. So now I come back here and I say, oh, that just equals -1. So now I have 2 plus 2i minus 12 times a -1. Oh, I can do this math now, right? A -12 times a -1 is a positive 12. So 2 plus 2i plus 12. Gather up my like terms. 2 plus 12 is now a 14. I now have a simple value of just 14 plus 2i, and that was all just being simplified by the top. So this whole part, if I just put it over here, I simplify that to just being 14 plus 2i. There's nothing that is being multiplied by these parentheses, so I'm just going to drag it over. So now I'm at this stage of the game. We found that we have 14 plus 2i all being divided by 1 plus 2i. Okay. Now I'm going to work on that I being in the denominator. I got to get it out of the denominator. So we've done tons of problems in which we've seen this problem, right? And what happens is, in order to get that I value out of the denominator, I need to multiply the whole thing by its opposite. So if this part of the denominator was 1 plus 2i, I'm going to multiply everything by 1 minus 2i. That's the opposite. So it's basically the same numbers, just the signs are opposite. But now, math is all about fairness. And if you multiply the denominator by that, you got to multiply the numerator by that as well. So I have to replicate the same thing on the top. And that's how we can just multiply things out of thin air, because this would cancel and just be 1. So in theory, it would not really exist. It's just multiplying by 1, but we can actually do the math to get rid of the I values. What we're doing here now is we're just multiplying across. So I have to multiply the numerators across, and I have to multiply the denominators across. Whichever one you want to work with first is fine with me. Let's work with the denominator because that's the whole reason why we did this whole debacle, because we need to get I out of the denominator. So I have two things, right, that's being multiplied by each other. So I have 1 plus 2i being multiplied by 1 minus 2i. Same idea that's going on in the first part. My first term is being multiplied by 1, and I got to be fair, it's going to be multiplied by negative 2i. And then my second term needs to also be multiplied by the same things. It's got to be multiplied by 1, and it's got to be multiplied by a negative 2i. So let's start it off. 1 times 1 is just 1. 1 times a negative 2i is a negative 2i. 2i times 1 is a positive 2i. And then 2i times a negative 2i is a negative 4i squared. There were 2i values in those, so you picked up 2i values, so it's I squared. Simplify here. I have a negative 2i plus 2i. That gets canceled. So now we're just left with 1 minus 4i squared. We know that I squared, that's the problem, but we know that I squared is a negative 1. So this would be 1 minus 4 times a negative 1. This is the same thing as 1 plus 4, which is equal to 5. So now we know that this whole big scary thing is just the same as 5. Pretty cool. Now I have these two guys that I have to multiply together. I will do the math maybe over here. Yeah, that's fine. So 1 plus 2i multiplied by 1 minus 2i. Actually, say, Christina, wait a minute. We just did that. We got to do the numerator. 14 plus 2i times 1 minus 2i. That's a little ugly. Okay. Same idea. I have to take the 14 and multiply it by the 1 and multiply it by the 2i, or the negative 2i. And then I have to do the same thing for the second term. I have to multiply the 2i by the 1 and the 2i by the negative 2i squared. Let me just see if I could pull this over, because I know that I'm getting close to this side, which there's a huge subscribe button. And if you guys haven't subscribed yet, please hit the button. Please. No, it's okay. I'm kidding. So, yeah, let me just clean this up, because I don't want to go, I want you guys to see the work and not like get, have the subscribe button being written over. So I'm going to get rid of this. So if you need to copy this part down, just pause the video. But otherwise, boop, there it goes. And I'm just going to bring this over here. Okay. So now we can do the math. So starting off with the first term, 14 times 1 is 14. 14 times a negative 2i is a negative 28i. Moving on to the second term, 2i times 1 is a 2i. And then 2i times a negative 2i is a negative 4i squared. Let's clean up the middle term. Negative 28i plus 2i. Negative 28 plus 2 is a negative 26. So we have 14 minus 26i minus 4i squared. Remember, the I squared is just a secret negative 1. So this would be the same thing as saying negative 4 times a negative 1, right? And negative 4 times negative 1 is a plus 4. So I can just erase this and say that this whole thing just turned into a plus 4. Clean this up. So if I add these two numbers together, 14 plus 4, that would equal 18, and then minus 26i. This is the answer for the numerator. So this is 18 minus 26i. Now technically I look at this and I say, I can't really, I don't know what my dog is doing, but we're going to push through. So we have this, right? So we have a numerator and we have a denominator. We can't really simplify this, so this would be the answer. However, I'm going to break it up into real and complex components. So what we're doing is we have 18 being divided by 5. And remember, if you have a lot of different numerator components being divided by a single denominator, you can break it up. So I can do 18 divided by 5. So 18 divided by 5, and then minus this component. So this is 26i divided by 5. And that's your final answer. Okay. So guys, pretty simple once we break it down into its components and we simplify and we just go slow and check our answers. But other than that, it's just basically adding, subtracting, multiplying, and dividing. And just knowing that I can never be in the denominator. What do you guys think? Let me know in the comments. If you want to give this video a thumbs up, you can. If you want to subscribe, you can too. The button's right here. But if you don't want to, that's totally fine with me as well. And I hope to see you guys in the next lesson. And check out the playlist if you want to see all of our complex number, imaginary number questions. See you guys all in the next lesson. Have an awesome day. Bye-bye.